Yesterday, we learned about the parametric curves. Today, we want to consider the calculus with parametric curves. We want to consider the derivative. What I want to do is I want to formulate the differentiation formula for the parametric curve. When x coordinate is given as f of t and y coordinate is given as g of t, where y is a differentiable function of x. So that means we can calculate dy over dx. This is a parametric curve. So x coordinate is defined with f of t and y coordinate is defined as g of t. The actual variable is t. So what we want to do is for dy, we want to calculate dy over dt, and dx, we want to calculate dx dt. If dx dt is not equal to 0, because if that is 0, then the denominator is 0 and that is undefined. This is the first derivative about the parametric curve. For the second derivative, we extend the principle. The second derivative came from ddx dy over dx. We differentiate the first derivative with respect to x again. So this one, dy over dx, can be regarded as a function. So what we want to do is this is a function, indeed function of t. So we will differentiate dy over dt dx with respect to t, and the dx over dt. The same principle we applied to the first derivative for the parametric curve. Those are the formula you have to remember or just derive naturally by understanding the nature of the parametric curve. Let's do a long example. A curve C is defined by the parametric equations x equals t squared and y equals t cubed minus 3t. We have a parametric equation. What we want to do in this problem is we eventually want to figure out the graph of the image curve by figuring out the first derivative and second derivative. You did the similar things in calculus 1, but we will do the same with the parametric curve. The first problem is show that C has two tangents at the point 3, 0 and find their equations. There are two parts in this problem. The one part is we have to show that C has two tangents at this point, and then we will figure out the equation of the linear line, which defines the tangent lines. The first step for this problem is we have to figure out what t value makes x and y value becomes 3 and 0. So we want to solve the equation, x value must be 3, right? So x equals t squared, that's how it is defined, and it should be 3. Therefore, t must be square root of 3 or minus square root of 3. And if you plug that into y, then you realize that both t values makes y value 0. So we got 2 points, and then we want to calculate the derivative. Since y and x coordinates are defined with a function whose variable is t, we do a differentiation with respect to t for both x and y. If you differentiate y, then you get 3t squared minus 3 over x is 2t. If t equals square root of 3, then the slope of the line at t equals square root of 3 will be, we just plug that into our calculation, then it becomes 3 times square root of 3 squared minus 3 over 2 square root of 3. So we calculate that this one becomes 3. So 3 times 3 will make 9. 9 minus 3 will make 6 over 2 square root of 3. So these two will cancel each other and becomes 3. 3 over square root of 3. So that is square root of 3. If t equals minus square root of 3, then dy over dx will be t equals minus square root of 3. So that is 3 times t squared, t is minus square root of 3 squared minus 3 over 2 times minus square root of 3. So again, the same kind of calculation will give us 6. And denominator is minus 2 square root of 3. So entire fraction will be minus 3 over square root of 3. So that is minus square root of 3. Any question for clarification?
Yes, Professor, after you've canceled or when you've reduced the 6 and the 6 over 2 root 3 to 3 over root 3, when you rationalize that, isn't that supposed to be 3 root 3 instead of just
I thought you were
itself?
asking that question. There are 2 ways to think about the problem. 3 is obviously square root of 3 times square root of 3, right? You agree, right?
Yes.
Yeah. So instead of 3, I would write square root of 3 times square root of 3 over square root of 3. Then the same thing will cancel each other and it becomes square root of 3, right?
Yes.
Yeah. So did I clarify the point you were confused about? Or do you want to use the rationalization method? If you want, then I can do that. So if we do 3 over square root of 3, it is a reverse of the it is rationalization. So if we do this, then the denominator becomes 3 and numerator is 3 square root of 3. So those will cancel each other. So that becomes square root of 3, right? Yeah. And so you can go either way. But if I skim one step and then it becomes confusing.
Yeah, it makes sense now. I just had to see it visually. I understand now.
Yeah. If t equals square root of 3, then the slope we calculated is square root of 3. We want to calculate the equation of the tangent line. At the beginning, it says it should pass this point, 3 and 0, right? And we want to use this information. Slope is square root of 3. So point slope form suggests that y minus y coordinate, which is 0, equals slope is square root of 3, open parenthesis, x minus x value, right? So we can write that as y equals square root of 3 times x minus 3. Any question? You can say if you forgot the formula for the point slope form, then I can state that for you. You're free to talk about that. Otherwise, I will just skip. If t equals minus square root of 3, then the slope is minus square root of 3. So the equation of the tangent line is y minus 0 equals, this time this becomes negative slope, minus square root of 3, open parenthesis, x minus 3. So y equals minus square root of 3 times x minus 3. Those are passing the same point in the xy plane, and they have different slope, opposite slope. One increases and the other decreases. Can I move on? Do you have any question about this? All right. The next thing we want to figure out is where the curve has horizontal or vertical tangent line. Find the point on C where the tangent is horizontal or vertical. The tangent line is horizontal. If dy over dx is 0, right? dy over dx, dt over dx over dt equals 0. So we are talking about the fraction. The fraction is 0 if the numerator is 0. So that is dy over dt equals 0 and dx over dt is not equal to 0, meaning the fraction is defined and the numerator is 0. What we calculated about dy over dt was dy over dt equals 3t squared minus 3. So we pull out 3 and then 3 open parentheses t squared minus 1. So this is 1 squared. So 3 times t minus 1 times t plus 1 equals 0. So t minus 1 equals 0 or t plus 1 equals 0. That means t equals 1 or minus 1. So what we are working on is a horizontal tangent line. We started the problem by putting the slope equals 0, and then we identify t values, which makes the slope 0. So we have to identify those points on the plane. So we will go back to the original equation, how the parametric curve is defined, and do substitution. T equals 1, then x and y coordinates are defined as t squared and t cubed minus 3t. So when you plug that into here, it'll be 1 and -2, right? And if t equals -1, then coordinate xy equals t squared and t cubed minus 3t. And that is 1 and 2. Because -1 cubed is -1, -3 times -1 will make 3. 3 minus 1 is 2. So those are the points where the tangent line will be horizontal. We want to figure out where the tangent line is vertical. The tangent line is vertical if dx over dt equals 2t equals 0. Basically, what I'm saying is if the denominator is 0, then this dy over dx is undefined as a fraction. So we made the denominator of dy over dx 0. And then tangent line is undefined, and that is vertical. So we have t equals 0. And if t equals 0, then x and y equals t squared and t cubed minus 3t, and t equals 0. So when you plug that in, that becomes 0 and 0. So what we did so far was we identified where the tangent lines are horizontal, vertical, and when the point crosses by calculating the two tangent lines at 1 point, 3, 0. The next one we will be related to the second derivative, and that'll determine the concavity. Determine where the curve is concave upward or downward. D squared y over dx squared. So we are calculating the second derivative. So ddx dy over dx, that is the definition of second derivative. I said we can put this one as a numerator, and then we realize that that is indeed the equation of t variable. So we differentiate with respect to t, and then denominator is dx over dt. So that equals d dt, and dy over dx is already calculated, and that is 3 squared minus 3 over 2t. Over dx dt is dt squared over dt. To proceed the calculation, I want to do this calculation. ddt 3t squared minus 3 over 2t. We apply the formula about f over g prime equals g squared in the denominator, f prime times g minus g prime times f. So this one will be 2t squared in the denominator. The numerator's derivative is 60 times denominator is 2t minus denominator's derivative is 2, and what was in the numerator is 3t squared minus 3. So the denominator is 4t squared and numerator is 12t squared minus 6t squared plus 6. So 12 minus 6 is 6t squared plus 6 over 4t squared. So we will go back to here. So the numerator is calculated, and that was 6t squared plus 6 over 4t squared over. We have to calculate this part, that is obviously 2t. And then this one can be rewritten as this one is a denominator. Just a denominator is 1 over 2t times the numerator is 6t squared plus 6 over 4t squared. So that becomes 6t squared plus 6 over 8t cubed. And then we divide by 2 on the numerator and denominator. And then that is 3t squared plus 1 over 4t cubed. So that can be written plus 3. So we pull out 3, then that is t open parenthesis 3 times open parenthesis t squared plus 1 over 4t cubed. What we've been calculating is d squared dx squared. So second derivative. Second derivative is calculated to determine the concavity, concave upward, then concave up, and if that is less than 0, then that is concave down. So we have to determine where it is positive or negative, and we notice that the denominator is always positive, and the numerator is always positive, and denominator is t cubed. And depending on whether t value is greater than 0 or less than 0, the curve becomes concave upward or downward. If t is greater than 0, then t cubed is greater than 0. And so c is concave upward. And if t is less than 0, then c is concave downward. So we are ready to graph the curve. To graph the curve, we have to gather the information. The last step is sketch the curve. So findings. That is, first problem is about two tangent lines. Two tangents at the point 3 and 0. And dy over dx when t is square root of 3 was square root of 3, and the derivative of parametric curve at t equals minus square root of 3 is minus square root of 3. The second finding was about tangent line is horizontal or vertical. There were 2 points where the tangent line was horizontal. Those were 1 and minus 2. 1 and minus 2 happened when t equals 1. And at 1 and 2, when t equals minus 1. And then we discussed where the tangent line is vertical. The tangent line is vertical at 0, 0, when t equals 0. And we know that the curve is concave upward for t greater than 0, and the concave downward for t is less than 0. Those are things which we have been calculating so far in this class hour. We have to sum all of them together to visualize with a graph. Let's move on. The first important point was 3 and 0. And the tangent line is a horizontal at 1, minus 2, and 1, 2. This is 1. And this is 1 and 2 when t is minus 1. And this is 1 minus 2 that happened when t equals 1. And at this point, this was 3, 0. There were 2 t values whose image becomes 3 and 0. Those were t equals square root of 3 or minus square root of 3. And the tangent line is vertical at 0, 0 when t equals 0. So it passes here, 0, 0 when t equals 0. So obviously the curve, flow of the curve goes like this, right? Goes like this and then go down, and t equals 0, and then t equals 1, and so it flows toward downward and then go upward. What we want to do is we want to draw the tangent lines. There were 2 tangent lines here, S3. One was positive and one was negative. And for this one, slope was square root of 3 at t equals square root of 3. And for this red line, slope was minus square root of 3 at t equals minus square root of 3. And then there were horizontal tangent lines. So do the horizontal tangent line, and at 0, we have vertical tangent line. And in this region, based on the concavity, the curve will go flows like this and like this, and at those important point, you have to draw so that the curve is tangential to the tangent lines. It's like this. So curve goes like this, and by this information, what we can verify is concave upward when t is greater than 0. So t is greater than 0, then it is from here to here. So that is U-shaped, so that is concave upward. And it says concave downward when t is less than 0. So that means this part of the curve is concave down. Obviously, that is concave down. So that means that is consistent with the results we produced with a second derivative. Any question? Let's do just one
yes,
more.
Professor, can you go back to the page where you...
Here?
No, it was the one where you pulled out
what?
1 over 2t. You did
1 over 2t? What? Where?
Second derivative. There was the page where you had the asterisk and you just pulled out 1 over 2t while you were doing.
This one? I'm not sure which page you're talking about. I'm not quite sure where 1 over 2t was. Is there anyone who can help me? Yeah, this is all I have. Let's move on to the next problem. Next problem is consider x equals 2 sine of t and y equals 3 cosine of t, and t is from 0 and 2 pi. So find dy over dx and the second derivative. So we will apply the same principle. Y and x are defined with a t variable. So we just differentiate with respect to t for x and y. And then when we differentiate 3 cosine of t, that becomes minus 3 sine of t following the formula. dx dt will be 2 cosine of t, right? So it becomes minus 3 over 2 sine over cosine is tangent of t, right? And then we differentiate that one more time. Second derivative came from ddx, dy over dx. So we can write dy over dx. So dy over dx, that is function of t. So d dt, the differentiation of the numerator and differentiation of the denominator. And so numerator is differentiation of this one. So numerator will be minus 3 over 2. Tangent's derivative is secant squared. And the derivative of the denominator is derivative of x. And so that is 2 cosine of t. So we can write this one as 1 over 2 times 1 over cosine of t. The numerator can be written as 3 over 2, and secant is 1 over cosine, so cosine squared. So 1 over cosine squared of t. So when we gather all the information together, we get minus 3 over for 2 times 2, and cosine happens 3 times. So 1 over cosine cubed of t. So that means that is negative 3 over 4 times secant cubed of 3. Any question? Okay. The next question is, for which values of t is the curve concave upward? For that, we have to use the second derivative. When the second derivative d squared y dx squared is greater than 0, then the curve is concave upward. What we calculated was that was negative 3 over 4 secant cubed of t, right? So depending on, this is a something cubed. So the sign of this one is identical to secant of t, right? So the sign of y equals secant of t and y equals minus 3/4 secant cubed of t are opposite because of this minus sign. So all we have to look at is the graph of secant. Graph of secant, this one is 1 over cosine of t, which means that is the reciprocal of the cosine function. So cosine function looks like this, between 0 and 2 pi. And then that is the reciprocal having vertical asymptote when cosine graph is 0. And that is flipped position because that is 1 over something with a vertical asymptote in the dotted line. So this red graph is y equals secant of t. What I said was the sign of secant of t is the same as y equals minus 3/4 secant cubed. So this is about concave upward. That means I said d squared of y, second derivative dx squared is greater than 0. But what is the condition for that? That happens if y equals secant of t is less than 0, right? Because this one is the second derivative. Right, and so secant is negative, and then secant cubed is negative. Negative times negative will make positive. And so we look at the graph, and then we find that that is, this is 1/2, this is pi, this is 3 pi over 2. So it is from pi over 2 to 3 pi over 2. Any question? So that's it for today. If you have question, then you can remain and keep asking me question.